So today we're going to talk about what a Riemann sphere is and how it relates infinity to complex numbers. So whilst infinity is a fundamental concept for complex analysis, it is defined as not being either a real or a complex number. Whilst for real numbers we consider plus minus infinity as being mapped to the real number line to represent limits as real numbers increase or decrease without bound. For complex numbers, there are infinite directions that can be travelled away from the origin. However, we can consider the mapping of the complex plane onto a sphere to represent this. This is known as the Riemann sphere. So let's imagine a sphere and the plane that contains its equator. We can model all the points corresponding to moving away from the origin without bound as converging to the top of the sphere. Therefore, for any point n on the equatorial plane, we draw the straight line that connects us to the north pole of the sphere. That straight line is going to intersect the sphere at some point. If P is on this exterior of the sphere, it will intersect the northern hemisphere of the sphere. If P is in the interior of the sphere, the line will intersect the southern hemisphere of the sphere. And if P lies on the sphere, so it's actually on the equator, it will itself be the intersection point. Mathematically, this is better defined as points of z with points z on the plane with the magnitude z being greater than 1 and mapped to the northern hemisphere. Points with the magnitude of z being less than 1 are mapped to the southern hemisphere. And points on the unit circle in the plane stay where they are. In analogy with R, the set of points made up of the whole complex plane, along with a single point representing the notion of infinity, is called the extended complex plane, which is denoted by CU infinity. This extended plane represents the extended complex numbers, that is, the complex numbers plus a value infinity for infinity. With the Riemann model, the point infinity is near to very large numbers, just as the point 0 is near to very small numbers.